Okay. So I wanted to come back to the fraction example that we did last week, just for a little bit longer, just to talk about maybe one or two things really quick. So we still have this fraction example, and what we did last week is we did some operator overloading, where we basically defined fractions and then gave them the ability to multiply them, divide them, and then do some other things like times equals and equal equal, and that sort of stuff. So what I wanted to do was just maybe throw in one extra function here and then kind of play off of that. So really quick, I think it would make more sense to make it a member function. So let's go to the fraction class that we wrote, and then let's just say for some reason we want to be able to get the actual like decimal floating point version of the actual fraction itself. So if I was to have something like 3/4, maybe I want 0.75 to be actually a value that I can get from it. So maybe I need to print it or use it as a percent or something like that. So let's just go here, and this is public already, so we'll maybe go here and make a public function, and then it would return a float. And we'll just call it get value or something like that. And so all this will have to do, right, is just return the numerator divided by the denominator. Oh, actually, I forgot to check. Am I able to be heard too? Is my microphone working okay? Yeah, okay, sweet, thank you. I had to replug in like all my audio stuff from my computer over the weekend. I didn't double check. Anyways, so yeah, let's just do that really quick. So we'll need to do just numerator divided by denominator, and then because these are both integers, then I think it would make sense to cast one of these to a float if I want the response to be a float, because otherwise this is going to do. Oh, whoops, that has to be the other way around. But if I didn't do this, then it would just do integer division, right? So it would give me, like, if it was 3/4, it would give me 0 instead of 0.75. So let's just make sure that this works really quick. So, I don't know, let's remove a fair amount of this, and then I'll just upload a different copy to Canvas. So let's at least keep these two. So let's just double check something like fraction 2. So we'll see out fraction 2.getValue. And so this should print 0.3, right? If it's 3/10. And then let's just make sure that actually works. Alright, so it runs, and yeah, it gives us 0.3. So that seems to work. So now we have a way to actually do like decimals with this. Okay. Well, why am I doing this, I guess would be the question. Let's try to do a weird case of fraction. So let me write fraction 3, and we'll make it, I'll just do the normal constructor. So let me just give this 5 and 0. Okay, and then we'll go down here and let's try to get the value of that one too. Now what's going to happen when I do this? Or I guess what would the value be of this fraction? So the fraction here would be 5 divided by 0, right? So if I run it, we should see, oh, this didn't work when I tried to do it over the weekend. Now it suddenly does. That's unfortunate. Maybe it only works when we do floating point. Well, that's unfortunate. Man, it actually worked. So it says infinity here. I guess when we do floating points, it actually handles it for us. Well, Okay then. So let's do a variation of this, I suppose. So let's just say get, oh, not float. We'll say get value int, and then this will just, instead of doing the actual floating point cast, let's just say it does numerator divided by denominator. So let's do a version that has the integer division. So in this case, if I had 3/4, it would be something like 0. Or another way to think about this is it would be the decimal equivalent with the fraction part thrown out. Or another way to think of it is floored, it's rounded down. So, okay, let's try get value int on this one now. So now if I run it, hopefully, I did test this over the weekend, it should, yeah, there we go, actually work. I guess floating point, they handle it for you. But it gives me a division by 0 issue, and the reason is because in main here, I set the numerator to 5 and the denominator to 0, and that's not something we can actually do in math, right? It doesn't make sense to divide by 0, and specifically the compiler doesn't have a case to handle it if it is integer division or modulus. It would also do the same thing. So we kind of don't want this to crash, right? So maybe something happens in the execution of our program where the denominator gets set equal to 0, and I'm not just arbitrarily setting it like this. And we want to be able to actually handle the fact that we got a 0. So there is a way to do that, and we can do it with any exception, but for the time being, let's just do it with this. I want to hit the stop button, but the WebEx thing's in the way. There we go. So the way we can handle that is we have this thing called a try catch. So what you can do is you can put a try, and what it says here is try to run this code. And if you if you get any exceptions, then we'll try to catch it. So what I can do is I can throw a catch down here, and then a block. So syntax for this is try, and then catch, and then the name of the exception that you want to catch. So for the sake of the first example here, let's just do exception, which is just a generic exception. So this is a parent class, so exceptions are a class themselves, and we'll get into that more in a little bit. But the base class for all of these is just the exception class. Then we're going to have specific ones like division by 0, or memory read access, or something like a seg fault. Those all have specific exceptions that we can handle instead. So here I'm going to return numerator.denominator, and I'll catch any exceptions that happen, and if there's an exception, then the code that's inside the catch statement is going to get executed instead of whatever was inside the try. Now, something to consider is if I was to run like 4 or 5 lines of code here. So if I had like int x equals 5, then any code that happens before the exception still does happen. It's just once it hits the error, it jumps down to here instead and stops executing the rest of the code. And so just to demonstrate that, let's say I have int x. Yeah, let's do this here. So let's say I have int x, and then here I set x equal to that, and then at the end I return x. So I'm just going to let x be whatever I'm trying to return. I'm going to set it equal to the numerator.denominator, and this is the line that's going to have the issue, and then I'm going to return it. Now, what I want to do here is say I want to handle it in some way. So perhaps if I get that issue, I'll just set x to 0 and I'll return that instead. Right, so if I run it now, really? Yeah, unhandled exception. Well, there's the exception handling right there. Did I type something wrong? It's not supposed to do that. It is supposed to jump down here. Let me Let me double check that. If I put generic exception type, it should handle all exceptions. I kind of wonder why it didn't. Let's try this really quick. So, Stack Overflow, or not Stack Overflow, this other website saying that it specifically wants runtime exception or runtime error. Let's try that really quick. If this doesn't work, I might have to try a different exception. No, it's still saying it. Why? I put it in a try catch block. Well, let me try it with a different example really quick. What should happen here is it should catch it and then end up down here when we have the exception. Maybe it wants me to finish the declaration. I suppose maybe I just don't know the C++ syntax. Let's try running it one more time, and if this doesn't work, I'm going to try to do a different example. No, it still doesn't take it. Super strange. Well, oh well. I suppose that's a bust. Let me do it with a different example then really quick. Or maybe my compiler is just strange. I don't know. I know I tested this the other day with some code I had written before and it worked fine. Maybe division by 0 is just special, because that's not the exception I tested originally. So instead, let's just, kind of for the sake of it, let's just throw in a integer pointer here, just called test pointer. And actually, maybe let's make a fraction pointer really quick. Actually, you know what? Maybe it makes more sense. Let's do this in main. So let me instead try doing. Actually, I still want that for later. Let me try making a fraction pointer called fraction4, and I'll just set it equal to null. So now if I do something like this, where I say fraction4 dot get numerator, or something like that, then this shouldn't work because this pointer is null and I can't access a null pointer, right? So this would be a null reference exception. And so if I run it, hopefully it should give me that, which, I mean, I don't see why it wouldn't. And there we go. Yeah, so it gives us a exception thrown read access violation. This was a null pointer, which is what we expected. So it's a null reference exception because I tried to get the numerator of a fraction that is null, which is definitely an exception. So let's try it with that really quick. So I'm going to try this code, and then we'll catch an exception, and then we'll see out something like exception caught really quick. And so hopefully this time it will still go there. Now why is it doing that? We might have to use a different example. I don't know why that's not working. I can double check. I should have the code here that I wrote that does work. Sorry about that. I don't know why this is not working. I suppose I should have actually tested it before I ran it here. I just kind of figured it would work because I don't know. Exceptions typically work okay. Templates. I don't know where I put the other one either. Well, I suppose we're going to come back to exceptions another day. I guess I'll talk about these Wednesday. I don't know why that's not working, quite honestly. That is the syntax for it, and I know that works. So I don't know why specifically here it's not working, but I'll play around with it before Wednesday, and I guess we'll talk about it then. Well, that's unfortunate. On the bright side, there is no assignment on that for another few weeks, so I guess I do have time to talk about it. But it's really strange to me that it's not working. Oh well. So then, I guess we'll talk about something else today. So, I think there were two things I wanted to bring up as far as the assignment goes on that note. So, I guess I should pull that open. Right. So I have here the skeleton code. And one thing I wanted to point out, because I actually learned it over the weekend, that C++ handles this specifically, which is not something a lot of other languages do, is when we write a copy constructor, C++ will actually do some strange things with it. So a copy constructor here is just a constructor that takes an instance of the class. So really all a copy constructor does is you feed it another instance of a thing, and it will just make a copy of it. So if I wanted to do something in my code where it was like big num a, and we'll just say equals star new big num, we'll just leave it like that and assume that there's a constructor for it. So if I wanted to do big num b, and then I wanted to, let's just say, set it equal to a. Then similar to how we were talking about the equal the other day and the fact that it compares the pointers, this should actually copy the pointer over rather than the actual thing, if it even allows it. Which I think it does. So when I write something like this, it might actually go and make a big num called a, and then char star, and then this is pointing to the digits, right, is what we had in this assignment, and then I think the other thing it had was like int length. So when I do something like big num b equals a, what it should do is it should go here and then just point to the same object. So the problem with that is that if I do anything to a, it should reflect in b as well. Maybe I don't want that because I want an actual true copy, or like a deep copy, I guess. So this, just for terminology's sake, this is a shallow copy, where we just give it a copy of the object by making it point to something. Maybe I want to instead do something like this, where I copy all of this stuff over from A to B. Length. So any changes I do to this one won't affect the other one. So I think we talked a little bit about this when we were talking about memory management and pointers, but if I end up copying a reference or a pointer to something, then any change I do to either of the two variables that are pointing to the same thing are going to affect the same memory, so they're going to end up modifying the other variable, right? So maybe I want to, instead of doing a shallow copy like this, where it just copies the pointer itself. Oops. Shallow. And then maybe I want to do a deep where I copy everything. So the digits goes over and the length goes over. Does that make sense so far? The difference between these two. So one is just a pointer, which is what it does by default, and then the other is maybe some defined behavior that we want where it copies over all of the things. So for big num, maybe that would be something like copying over the whole digits array and then the length variable. Right. So that's kind of the purpose of a copy constructor, which is what we have here. So what we're going to do is we're going to create a constructor that's going to take the original variable that we want to copy and then just copy over all of the actual individual things. So something like this, we would just want it to take the digits and copy it over and take the length and copy it over in the context of the constructor. So, something like this length equals original length. I'm not going to write the code since it is an assignment, but we would copy over the length, this length equals the length of the original. And then we would do something where we copy over the entire character array one by one to the other new thing that we're constructing. So the main reason we do that is so that we can actually do those deep copies where we don't have the pointer. And they're kind of common to do in a lot of languages, but C++ apparently explicitly handles them and does some strange things. So again, I don't really have any code written here because this is the skeleton, but let's just say I was to go down here and do the plus operator. So this is going to return a big num, right? It's just going to be the first plus the second. So, you do whatever code you need, but let's just say I do big num a, and then I don't know, assuming I already have the constructor written, I just initialize it to 20 or something like that. So I set the number equal to 20, and then I just return that instead. So what C++ does, I've learned, is if you go to return a class type in C++, it will actually call the copy constructor without you asking it to. And it will do that if this is not a pointer. So if you explicitly say, I want to return a class object, it will take whatever you're returning and call the copy constructor on it and then return the copied big num or class type that was constructed with that constructor. So the reason I bring this up is because you might get unintended side effects in assignment 6 if you don't know that. So make sure that you actually implement this copy constructor first before you start doing the operators. Otherwise, you're going to notice that you get a bunch of uninitialized data and it stops working halfway through, and it won't be clear as to why because you never really called that constructor and the compiler just kind of does it for you. Why it does that, I have no idea. Normally, you have to explicitly call something like that if you want to make a copy, but I guess here it just automatically does it if it notices that you have one. And this program does, so we kind of have to consider that. Any questions on that? I just wanted to make everybody aware before you start getting weird things when you're writing these programs, or this program. Right, so one other thing to mention with regards to programming and the assignments and stuff. So I was asked specifically to just make an announcement. If you're using Visual Studio Code and you're connecting to Sally or Bobby or some sort of school server, is to stop using that, at least Visual Studio Code, because apparently when Visual Studio Code does that whole SSH protocol where it connects to the server and you run it, apparently it opens a whole lot of processes, way more than it normally should. And that's why a lot of people have been getting kicked off. If you've seen the Discord, people have been posting about it, and I'm sure it's happened to some of you as well, is that it will start telling you that it can't fork a new process or something to that effect. And I guess the server is banning you for using too many resources, and I guess that's just a side effect of Visual Studio Code. So if that's happened to you, then I guess my suggestion is to use Visual Studio Community Edition if you can, like the normal purple one. or if you go to run it, I know it's tedious, but if you go to run it, just copy it over using something like FileZilla and then run it with the terminal, because that's the reason people have been getting kicked off, and I guess it's putting a bit of stress on the server. So I just was supposed to move that along. All right. Well, I guess we're not doing exceptions today, since that didn't want to work. Oh, yeah. So I have a question for the constructors in big num. As per string and the ones after that, do we store the string into one of the variable members? Yes. And same thing for the other constructors. Yes, yeah, you're exactly right. So the way that this big num works is that it has really two fields that you care too much about. You should initialize this one too. So invalid number just says whether or not this number is containing valid data. And really the only time I think that doesn't matter, or comes into play, I guess, or does matter, rather, is if you're subtracting things that would give you a negative number, and the reason being is just because we only want to store positive things with these numbers. So that's the only place that comes into play. But we have these two other variables. So the digits character array is going to point to an array of characters with their decimal equivalent in ASCII. And then the length is just the length of that actual array. So when you do a constructor, because it is a character pointer or a character array, a pointer to a character array, then really it is the same thing as a string, pretty much. So when you do the string constructor, you will just need to copy over the characters from that string to the actual thing. So that's what the string constructor will do. And I have a question for that. As per the string, we store the string into one of the variables. Yeah, so you'll store the string into this basically, and then the length you'll be able to discern from the string. So it's however long the string is. And then same sort of thing with most of these other ones. So the copy constructor is just going to do the copy that we talked about. String number is going to copy the character array. Big num, like the default one, I guess it says to make a character array that contains nothing, so I guess I would just initialize it to null. It says length is question mark, maybe just make it 0. Or alternatively, you can make it 1 and then just initialize it to 0 or something like that, I think would be okay. I don't think this one's super important. I think it's just there so you can do declarations. And then the tricky one, I guess, might be this unsigned long one. And I think the way to do that would just be to actually turn the long into a string and then use that string with this constructor instead. Or basically just copy the same code. So really you'll just copy the string into the character array, if that answers your question. Right, so the other thing I guess I was going to talk about, we can still use the fraction class for it, I suppose, was doing things kind of more generically. So let's just say for this fraction class that I wanted to sort these for some reason. Then I could really just write bubble sort. Let's just say I'm going to write bubble sort. And I guess if we consider first, let's just say I want to write integer bubble sort just so we have it as a refresher. Then what I do is I say for int I equals 0. So let's say I have, let's just say integer array. And I'll call it I array. And then it equals whatever. And so I want to sort that. So I could do for int I equals 0, I less than ir dot size, so however how long it is. I guess it would be length. And then I plus plus. And then I do a second for loop, so I say for int j equals 0. I'm just going to ignore that boolean for like found or whatever. We'll just copy and paste it from one of the assignments I wrote earlier. So j less than ir dot length. j plus plus. I guess we want to make this shorter at bare minimum. So you say j equals 0, j less than ir dot length minus I. That should be okay, I think. And then j plus plus. And then the idea with bubble sort was if some array element, let's just say it's going in non-descending order, so it's getting bigger or staying the same as we go from left to right, then if IR sub j plus 1 is less than IR sub j, then we, let's just say swap, and again, I'm just not going to write the whole code out, let's just keep it kind of generic. So I swap the two of them. Oh, that's j. J plus 1. And then I swap that with IR sub j. So assuming this is correct for bubble sort. So the general idea, right, is just if we find something that's out of order, we swap it, and then normally we keep like a boolean found to optimize it or whatever. So really quick, let me make a copy of this. Okay, so I have a new version of this, and let's just say instead of an integer array, I wanted to store, it doesn't let me erase that, that's unfortunate. I guess we're just going to go back to the other one. So let's say I wanted to, instead of an integer array, I wanted to sort the fractions that I just made. So for some reason I have a fraction array, and I want to sort that instead. So really I'd have to do all this code all over again, right? But it's pretty much just the same. The only difference here is that instead of comparing these directly, which I suppose I could do, I would need to use that getValue function. But really the rest of the code is all the same, right? So bubble sort doesn't change all that much. The same general idea applies, that if things are out of order, we swap them. So I could continue to do that for whatever class that I'm actually writing, and really just we would keep doing the same thing and then maybe change one thing about it, right? And I'm going to keep it this way, so you notice I don't have the getValue, but that's okay. So what I can do is I can actually have the compiler generate that for me. So really quick, let's try to write the code for that. So the way I do that is with what's called a template. So if I write template, what it will do is it will just allow you to put whatever type you want, and it will fill it in as it needs it. So I'm going to say template here class t, and then I'm going to write the actual function. So we'll just say void bubble sort, and then we'll take a vector of t. So the actual syntax here for template is just template and then these angle brackets and then class and then whatever it is that you want to name the class. So what I'm doing here is I'm actually creating a new type that's temporary and only exists in this function, and that type is called t. And so I'm allowed to do it anytime afterwards. So what the compiler will do here is it will actually take this t and fill it in with whatever type that it is that you need it to sort or to use. So in this case, if I was to write some code here and I wanted to sort the fraction class, it will take t and it will replace it with fraction for every single time that it occurs. So the reason this is nice is because I can, if I know I'm going to rewrite the same code over and over again, or I need it multiple times, I can actually just have the compiler do it for me, and it will fill in all the types as it goes. So really quick, let's just get some bubble sort code that I wrote from the first week class. Where is that? Okay, so I'm just going to use the one from assignment 1. I can't find the other file. Is this the solution? No, I don't think it is. Oh, there it is. So we have this one from earlier, and we could use it to generate the car one too if we wanted. Alright, so what I'm going to do is I'm going to basically just write the same code, but I'm going to replace it with that generic type T. So here we'll just say list of j. List of j plus 1. Alright, so that should be, oh, right, this would be list then, right? So really this is just bubble sort, but we've kind of generically written it to use some type T that is just not defined. Okay, so really quick, just to make sure that this works, let's try and use it on a vector of integers really quick. So I'm going to make a vector of integers, and you'll notice here, because a vector actually is a template as well, that it uses that same angle brackets, and we've been using it the whole time. So whenever you see those angle brackets, it actually means that it's a template, and that the type on the inside is one of these generic types that gets replaced later. But anyways, I'll call this list, and we'll just leave it like that. That should be fine. I don't think I need to include the vector library or anything like that. So let's just push some things into this really quick. So maybe we'll push back to, and then 8, and then 6. And then we'll print the values of it. And we'll just say some I and line. Okay. So now if I want to actually do the sorting, then I should be able to just say bubble sort, and then when I call it, I'm going to need these angle brackets now. So similar to how we have them down here, up here is where I wrote it, then I'm going to need to do the same thing when I actually call this function. And all that really says is I want to call it with the type being, in this case, an integer. So when you do it like this, it will go to those angle brackets and it will say, I'm going to now fill in all of the t's with whatever you called with, so an integer here. Right, so it seems to be detecting it now, but I haven't actually finished it. And then we just call it like a normal function. So I'm going to call it with list, and hopefully it should work now. So an expression preceding parentheses of a parent self-call must have pointer type. Oh, well, it doesn't recognize the vector, I suppose, for one thing. Let me include the vector library. Hopefully that'll fix it. I scrolled too far. Okay, that seems to be it. So now, really quick, let's just make sure this works. So if I run it, it should give me the list sorted, hopefully. So it should print 268. And so if we open it, it does not. Oh, you know why? I didn't pass this by reference. There we go. Now hopefully it'll print it correctly. 862. Okay, so I guess this sorts in descending order, but my point still stands. So you'll see that it actually went and it created that function, and it just filled in the types with an integer. So that's really helpful because now we can write this for really any data type. So if I wanted to, I could also make this a float array and make this something like 2.6 and 8.4 and 6.7, and then change the call to be a float as well. And you'll notice it should still work. Right, so the 0.3 is coming from down here. Maybe I should remove it. But you'll notice it was able to sort the floats now instead of the integers. So really, we've been using this whole time with vectors, and it doesn't really have to just be functions like this. We could also do templates for a class. But yeah, it will go up here and it will actually fill in the types and change it so that you have a different function each time. So let's try to A, do that for a fraction, and then B, we'll maybe consider what the compiler is actually doing. So whereas in a lot of other cases it's kind of just filling in some references and not copying and pasting anything is what the compiler usually does, it actually does something different here. But anyways, let's try to do this with the fraction class really quick. So let's just say I have these two. Let me try to do something like fraction 3 is 5 over 6 now. Let's try to remove that error that we had. So instead, let's make a vector of fractions, and then we'll just push back fraction 1, fraction 2, and fraction 3. And then we'll change the type to fraction. So now what this should do is it should generate bubble sort, but for fractions, right? So we'll go up here and it will set the type t that we declared to be a fraction. Oh, does t in template class t need to be defined somewhere else in the code? Yeah, so actually good question. So when you write template and then class and then whatever name you decide to go with, t is the common thing. That's actually the declaration. And so what it does is it creates a temporary, it's not really a local, it's not a variable, I wouldn't say, but it tells you that that's the type that's going to exist for the following function. So when you write that actual template class variable name, whatever it is, or type name, it will take that type name and it will use it for the rest of the function. So you just need to do it right above the function name, and that's all that is required for it. Actually, another thing to note about it is that it's totally fine to throw in multiple of these too. So if for some reason I wanted another class type, I could say class U, and then now I have, another type that I can use if you need multiple as well. So you can declare as many types as you want. The only caveat is that when you actually call the function itself, you need to specify what those multiple classes or single class, whatever variation you do, is. So if I was to call this now, I would need to do something like fraction and then int. And then it will go and it will fill in all those types with the corresponding things. So I think one way to think of it is almost like a second parameter list that you have every single time you call this function when you do templates like this. And those parameters are now types. So they're generally class types, but you can do something like a primitive type, like an integer or a float, like we just did. But you basically have two parameter lists now, one being the type to fill in when you actually call the function, and then the other being the normal parameters that we're used to, if that makes sense. Right, so I guess I should delete this now. Yeah, but good question. So, right, so I guess what we have now is we have the same code, which just worked on integers and floats, and we were going to try and call it for fraction. And I didn't change anything about it, and part of the reason I didn't do that is because we were saying that there's something special about the fact that I need to use a class type. There's something special about it when I actually do this, and we should see that it will call us out on it if I try to compile it, which is that binary less than does not have a operator or a predefined operator. So part of the problem here when it tries to generate that is that fraction, so if this is a list of fractions, then when I compare lists of j and lists of j plus 1 now, it's comparing fractions, right? And the way we said we wanted to do that is by doing get value, because it actually does like the floating point value, and then we can do some sort of real comparison where it's not just, this abstraction of like a numerator and denominator that we had. So the problem with that is that I can't really do dot get value here, right? And again, if I was to do that and just write a separate function, then I kind of lose the point of a generic, which is the fact that I don't have to rewrite all this code every single time, right? Is kind of the advantage of this. So I'm not actually able to, it's not throwing me an error right now, which is kind of strange, but it is not going to be able to call get value. So if I actually compile it, it should tell me that error. Oh, okay, it doesn't tell me. But I can't really do get value because what if I wanted to make this list type an integer or a float or something like that? Those don't have the same functions that something like a fraction has. So I'm kind of in an impasse here, right? I can't actually generate a bubble sort that works for this fraction class because it doesn't know that I need to get the value, and that's what I need to compare when I'm actually doing a comparison between these two things. So the way around that, you might be guessing already just from the error message it gave me, is that we could just use operator overloading. So what I'm going to do here is I'm going to go back to this operator section that we wrote, and so I'm going to make friend static, and then I guess it would be a boolean. So boolean operator, and I'll just write one, but we would really need to write all of them. So here we used less than, so let's make that a less than. So operator less than, and it will take two fractions, fraction f1 and fraction f2. Okay, so now we can overload that. So I'm just going to go up here really quick, throw that in there, we'll make it static. Cool. So now we can define this actual operator that it's using to do some different behavior. So what we wanted to actually do is we wanted to compare the values of the fractions, right? So I could say get value of fraction 1, and then I could use this and say f2 dot get value. And then since this itself is kind of what we want, I'm just going to return that. So now instead, whenever I use the less than operator, it will come and call this one. So if I try to run it now, it should actually be able to generate it. And it does. So we see that it works. And then it sorts these. And again, this should be in descending order. So 5/6 is definitely bigger than a half, and then 3/10 is definitely smaller than a half. So it does seem to sort it. And I don't think this was the original order that these were in either. So it definitely seems to be actually swapping them. Cool. So if we just use the generic operators that work on any integer or float or whatever, and then give them overloads to tell them what to do, we can actually rewrite any of these generic functions and have them work just with any sort of class type. And so one last thing we'll do here is let's just say vector int list2 dot push back 3. We'll say it like that. So just for the sake of showing that it works. So I am able to use this function with multiple types in the same program, and it's totally allowed. Oh, I didn't actually print it though, so it's not showing up. So let's make this list 2 really quick. Alright, now if I run it, we should see that it prints the fraction list sorted, and then it prints the integer list sorted, which would just be 8 and 3. So I'm able to use these generic types also with multiple types. So I just need to specify it before every time. So it's not limited to just one. You can make it happen as many times as you want. And really it'll just go up here and fill in the types. So maybe we'll do a little bit more in terms of examples with that in a moment. But I just wanted to talk a little bit about the actual stuff that the compiler is doing with it. So when it takes that, and I guess maybe I should just go back here. So this is the one we wrote before. So we had something like this, and now with the generic types, rather than this being named fraction, I'll just erase all that, I suppose. Then we could just call this t now, right? So it has some sort of generic type that it's filling in for it. And I suppose that's really the only place that we had that. We had like a t temp somewhere, right? That we used for swap. But what the compiler is actually doing is it's not like a function call. So whereas when we do a function call, it actually goes to the place and then passes those parameters just based off whatever the variable is. The compiler actually goes and before running or doing anything, it actually goes and fills in all those t's with the types it finds in the program. So from the code I wrote earlier, it's actually going to go here and it's going to look at all of these t's that it sees, and it's going to replace them with all of the types that it knows I called it with. So I called it with a fraction first, and then I called it with an int afterwards. So I don't want to write this all out, but what it will do is it will generate that bubble sort. Where it takes a vector of fractions. And it will go, and I'm just going to write it in black, and it will replace all of the t's that it saw in the earlier code with that. So ... we have the rest of the code there. And then it will go and it will also, after that, it will generate the definition for bubble sort. And then it will replace all of the t's with int. So whereas with a function call or a lot of other things that we've been doing, where it does it at runtime and kind of, passes the variable, or like a pointer to the variable usually if we're doing it by reference, this here, the compiler actually just generates all of the code for you. It doesn't show it to you, but it generates all the code for you, and then that ends up in your executable. So it actually does physically go here and replace the t with an integer and with a fraction, and then it copies and pastes the code somewhere around here twice. So it's just something to be aware of, is that it actually does generate the full code with you if you were to write out that whole function by hand. It just kind of simplifies it a little bit. So it saves you the time, but it still does write the code that would be duplicate that we would have had beforehand, if that makes sense. Any questions on how that works so far, or at least how we get it to work with this type? Right, so let's maybe do one or two more examples here. So let's do an example where we have multiple variables. So I think an easy example of that would just be find a minimum. I should say Boolean. Min of two things. So we'll say t var1 and t var2. And then since it is a template, I need to write that in again. So template, and then we'll say class t. Right, so I could sit here and I could find the minimum of these two things. Actually, maybe now is a good time to talk about another programming thing I've been meaning to talk about for a while. But let's just write this first. So I guess if we wanted to find the minimum of two variables, then we could check if var1 is less than var2, then we know, oh, whoops, this isn't a bool. So t. Then we return var1, and then else return var2. And that is the same operator, right? So if I wanted to find the minimum between two just random variables, then if one is less than the other, then we know that that one's the minimum. But if it's the other way around, then we'll just return the first one, or the second one, rather. So I guess what I'm trying to get at here is that we can also return the type that we actually declared. So you'll notice if I was to compare two integers and find the minimum, then the function, or the type that I want to return is also an integer. And if I wanted to find the minimum of two fractions, then the type I want to return is also a fraction. So the type that I'm returning here actually matches the type that I am operating on. So it's totally okay to make it a return type as well if you really wanted to. And then just to verify that works, let's go down here and we'll see out find min of fraction, and then we'll just say maybe fraction 1 and fraction 2. And I think we wrote a cout override for fraction, so this should be fine. And it's kind of hard to tell where it is, but it should be right here. And it says that 3/10 is the minimum between 3/10 and 1/2, which does seem to check out because 3/10 is definitely smaller than 1/2. Okay, so this seems to work just generically. We can kind of throw this in here and just, it'll fill in the type. So I think there's only one other thing that I wanted to talk about really quick. And it doesn't have to do with templates, but I've been meaning to talk about this for a while, and I think just because we have some extra time here that it might be the best place to talk about it. So actually, let me bring this back really quick. So let's say I want to rewrite this, and I just maybe want an easy way to do it. So there's been an expression here that I just haven't been using. And really, it's not something you always need to use, but I like to use it at least, which is called a ternary expression. And so what you can do with that is it's basically just an if and then an else, except it's in one line. I don't know, maybe somebody talked about this in 135. I just figured it might be a good idea to throw it in here. If I wanted to write the equivalent code that I wrote above, it would actually be this. And then just to verify that that works, let's make sure that this still returns the same value really quick. So we should see that this prints 3/10 again. No. Find min must return a value. Oh, whoops. Return. And you'll see that it does. It still returns 3/10. So maybe I should actually bring back the code so we have some sort of reference here. And then let's make sure I keep that end line that I wrote. Yeah. So a ternary statement, you don't have to use it, but I just throw it in here just because I think it's kind of helpful to have. Basically, the ternary statement is just like an expression, a question mark. So you're kind of like asking a question, and then you typically do variable 1, variable 2. So what this does here is it says variable 1, variable 2, is that less than it? And so it will take that Boolean and then evaluate it. And then if it is true, then it does the first thing, else it does the second thing. And the difference between this and an if and an else is that it actually returns a value. So once it's done evaluating this, it will pick either this one or that one. So really this line is equivalent to what I wrote up here. So this is the if part. This is the part that gets evaluated if it is an if, and then that's the else part. And I think this is useful just because it's one line of code, and I think that's easier to read sometimes than this whole thing. But I also bring this up just because we were talking about operator overloading recently, and there were generally those ones that you could overload that had two operators, or not operators, two operands or one operand. So we have like those binary and unary. But it's also possible to have a ternary one like this, and it doesn't show up too much, but it does exist. I guess, is that clear? I just kind of shoehorn that in there, but I think it might be useful to have. I'm not going to test you on that, I don't think, but I personally like to use it when I'm programming, so I figured I should mention it. Alright, well, we still got 10 minutes left. Any questions on generic types? I know we kind of went through that quickly there. So still want to figure out what's happening with that exception stuff. I don't know if we want to spend the last 10 minutes doing troubleshooting though, because I imagine that's no fun. Do you declare templates above int main? You don't have to. So just, actually, I guess that's a good question. You know what, let's actually think about that. I think you don't have to. I think you can write prototypes. Let's write that really quick. Yeah, it's actually a fair question. I don't know. Let's double check. So if I was to just write a template here and just say template t void bubbles sort, maybe we'll just do the same one we did earlier. Vector t list. More than one instance of overloaded matches. Am I able to just write it like this? No, apparently not. So good question. Thank you for bringing that up. I didn't think about that, but yeah, it appears that you do have to write it before main. It doesn't seem like prototypes work. Maybe I have the syntax wrong or something. I've never actually written a prototype for a template class. I usually just write them straight up like that. But yeah, fair question. So I think you do. Although again, maybe I just have the wrong syntax. So I think that's pretty much everything I wanted to talk about today. Unless you guys want to do another template example, I can probably try to think of something. Actually, I guess there is one more thing we should talk about really quick. So a few weeks ago, we did an example. It was when we were talking about memory allocation. We did an example where we were talking about writing a vector, and then we kind of made that list. And I ended up writing two classes. One was called like an int list, and the other was called maybe a person list, I think was the other one. It was like a person class. So I don't just have to use templates for functions. I guess I should mention that I can also use them for classes. So really quick, let's just go here, and I'll just write kind of a generic thing. Maybe I'll actually go grab, let me see if I can find it really quick. I was having a hard time finding code earlier, but exam questions. Yeah, here it is. So we have this list. Oh, this isn't actually, this is the CPP. I want the header. So a few weeks ago, I wrote this list. So we had like a class person, and then this here, and then we had the same thing with like an integer list. So let's really quick, let's just try to take this, copy, and then I'm going to throw it down here. So I said earlier that a vector does use a template, and we can kind of do the same thing if we wanted to. So I'm just going to make a class called list here. And then instead of taking an integer like we had before, I can rewrite it to take a generic type. So I don't have to just limit myself to functions. I can actually do the same thing if I just write it above a class declaration. So here I'll put template. And then the syntax seems to be in C++, type name, and then the thing. So when you're doing a function, I think there are multiple things you can put. I think you can put class, and I think there's another thing you can put, but I think generically class was better. I remember reading about it. There was some minor difference between it. But I recommend when you do function generics or function templates like this, that you just write class and then whatever the name of the type is here. When you do template, I think you might also be able to put class, but this reference I looked up says you can do type name as well. Yeah, I suppose it takes it. Alright, whatever. We'll just keep it as class. But I guess point being, you can also declare a template right before a class and use it as well. So here, if I wanted to, instead of making a list of integers, I wanted to make a list of type T, I can totally do that. And kind of like how we said earlier, that when I do template and then whatever the type name is, and then I call it, it works, or not call it, but I put the little angle brackets thing, it will end up using that type for the rest of the function just below it. Then the same thing here, it will work just for this class. So actually maybe something to consider really quick if we go back to this. If I was to try to use T outside of this class, it's not going to work. It's just something to throw out there. So if I just said TA and try to make a variable, it doesn't know what T is. Just to clarify, I know it was asked earlier, but the type only exists for this function. You can't use it anywhere after that when you write a template. So same thing here. I'm able to use this now for this whole thing. So it will use this class T. Now I have that be the array. Everything else should probably work. I don't think I explicitly do anything here. Oh, okay, I guess we have a temp pointer. So let's make that the type T. Imagine everything else is fine. List. This should work. Let's see if it does. So really quick, let's try to make a list. And again, when I instantiate this, similar to how you've done with a vector, I need to specify the class type similar to how we were doing with the function like bubble sort. So if I said list and then made it integer and then called it int list, let's just try to add something to it and we'll just see if it works. So int list dot add, and we'll say 4, and then we'll see if it works. Again, I did just kind of copy and paste this, so maybe there's some errors. So expression not found. Oh. No, it's from me writing the ternary statement. There we go. And it seemed to compile, so that's good. Very cool. So now with this code that we wrote a few weeks ago, which I apologize if you don't remember what exactly it did, I just figured it would be easy to throw it in here. We can actually just change the type generically. So effectively the other week, we created a vector, like our own vector class, and now it works with whatever type, just like a vector does. So now it will actually allocate that array based off whatever type you give it.
So I think generics and templates like this are super powerful. You can kind of just use it to write a class that takes whatever type you want. And I think that's super useful for things like lists, or things where you want to do sorting, or things where you maybe just have some sort of generic function that applies to every single class type. Like maybe if we were in a game, or when I'm writing apps, for instance, I might have a generic type that I use to add graphics to the screen. And so, maybe everything has an add graphics, and we could use it that way. But really, it's just a quick way to generate code that you would otherwise have to write by hand over and over again and copy and paste. Is we can just quickly do it with a template. That's kind of the purpose of it. So, any final questions on that? I apologize if it was a bit rushed. I wasn't expecting to talk about it today. I was hoping to talk about exceptions, but that kind of fell through, so oh. Alright, well, I suppose I will stick around for a couple more minutes if you have questions, and if not, I will see you on Wednesday, and I will figure out this exception stuff so that we can actually talk about it, and it doesn't just give me compiler errors, and we accomplish nothing. Alright, so I guess I will see you guys on Wednesday.